Hi there. So I have a lot of slides. I always have a lot of slides. So some of them I'll be going through a little quick. But the premise for this is just, how to build secure infrastructures. And with all the attacks that are going on and the ones that you guys even here in Poland have seen, I guess about a month ago or so, all because of the after stuff and how your government, the policies that they make, I think it's relevant to everyone. So basically, just real quick, just going over what are we trying to protect against, going through the mitigation techniques. Some of them are fundamentals, but nobody does the fundamentals. It's amazing to me. How many of you do ingress filtering? Ingress filtering? Yeah, and some of you go like this, Yeah, it's all time consuming, right? But the problem is that most of the attacks, why they're successful, is because people do not do the fundamentals. And then, of course, if you're a larger environment, there's also some techniques that you should be looking at that will make certain mitigation techniques much more efficient. So what are we protecting against? Right, the problem is, and I don't know, this is a cartoon in the US from a very long time ago, where it basically says on the internet, nobody knows you're a dog. Right, so you can be anybody and you can be distributed anywhere around the world. You don't really know where the attack sources are, right? All you know is all of a sudden you're getting 20 gigs of traffic, right? I was just looking at some emails today where people were, reporting that, hey, I'm getting 20, 30 gigabytes of certain UDP traffic, and they're asking the community to help, right? Help filter, because that is a heck of a lot of traffic. So this is going to be too small for you to read out in the audience. However, the premise here is simply that the attack landscape has changed quite a bit. I mean, over the last 20 years, attacks have become much more sophisticated. Right? What started off as mostly flooding traffic has now become issues where there's botnets that are being created where it's really hard to detect them. Right, because they use different packet sizes, they change their port numbers, they're registering different DNS names. So it's really hard to actually track where the sources are. And so the attack landscape is getting much more sophisticated. And the major problem is, we care about distributed denial of service attacks, where basically you can be a victim where either you're an enterprise, you're a government entity, or you run certain web servers where people don't like what your actual beliefs are, and they attack you, right? And instead of having over only 100 or thousands of machines, I mean hundreds of millions of machines can be part of the sending of the attack traffic, right? It's a big problem, and how do we actually defend against this effectively? The motivations have also changed. So there was just recently a new Arbor Networks report. Every year they do a survey about attacks that they've seen, the latest threats and just issues. So it used to be that people used to just kind of create attacks for fun, right? It was teenagers, they wanted to see whether or not they could break into some government sites, or wanted to get some notoriety. Look, I broke into Microsoft, yay. It's now become a criminal activity, right? It's criminal. It's also espionage. There's terrorists involved, and patriotic and principles are involved, right? And so it's serious business, and the people that are actually creating these attacks are criminals. So it's not just for fun anymore. It's actually definitely for profit and because of idealistic beliefs. So if we look at, the threat economy in the past, at the end value, really people wanted fame. Some of it was based on theft, or some also, espionage, either corporate or government. But if we look at today, it's much, much more complex. And really with the end value, it's really more about money. At the end of the day, most all criminal activity depends somehow on money. And you will have access to these slides, so I don't want to go through all these little things in detail. But the main gist here is that defending your networks against compromise and potential denial of service is really a difficult problem. However, to actually protect against some of these activities doesn't have to be that hard. And people always say, oh, it's security is so difficult. It's not. It's the jargon that makes it difficult, and the vendors who are always trying to sell you new products, so they keep creating new words for the same old thing. At least that's my belief. And I used to work for a vendor, so I used to run networks. I used to work for a vendor. Then I was kind of consulting on my own for a while. Now I work for ISC. So I've kind of seen it all. And I really am quite passionate about security. And trust me when I say that, it really doesn't have to be that hard. And if you do end up configuring some of the fundamentals, a lot of the attacks and threats will not be relevant in your environment. So let's talk about proactive mitigation techniques. Right? The most common threats and attacks are one of the following. So unauthorized access, and primarily most of you would at some point in time have had some insecure hosts, right? You don't do the device hardening. Eavesdropping, if transmission isn't encrypted, right? Wireless networks here, if you're checking your email and you're not using SSL, probably sending your passwords in the clear. I don't think any of you would do that, hopefully. Hijacking, taking over communications, spoofing, and denial of service attacks. So spoofing, IP address spoofing. There's a lot of people that do not do any ingress filtering that basically filter on bogon addresses. And it's interesting because every couple of months there's some huge attacks that use spoofed addresses. So if nothing else, I would hope that many of you really would take into consideration filtering on spoofed addresses, IP addresses. Some common mistakes that IT people make. One is connecting systems to the internet before hardening them. Connecting test systems to the internet with default accounts and passwords. I worked for a mobile carrier in the US that's fairly large a year ago. And what was really fascinating to me was looking at the backhaul network and looking at the devices that they had. And there was a couple of timing devices, and nobody really ever thought to change the default username password on them, right? And on these phones, the cell phones, right, I found an application actually that said router passwords. I downloaded it, and I had access to 3,000 different devices with their default username passwords. Right, so if you don't change them, it's very easy for somebody to create a script and somebody to just say, run script, and, they do address scans, see whether or not they can get in. I mean, these are the simple things, and you really, really do have to be very cognizant of changing default username passwords. Other very common things are, running unnecessary services. The problem is that in a lot of devices, you don't necessarily always know what are the default services that are turned on. So in your Huawei, Brocade, Cisco, Juniper, name your favorite vendor, you always need to know what are the services that are on by default, and if you're not using them, then turn them off, right? Disable them. I mean, it's kind of a pain in the butt, but it's just, this is how you defend yourself. So if you look at overall architectural considerations, as I continue with some of these best practices, addressing architecture. And I think 2 years ago, I was at a PLNOG, and I gave a specific talk on securing IPv6 networks. I really get discouraged when people say, oh yeah, IPv6, well, I do the same thing that I do in IPv4. It's very discouraging because, IPv4 has been band-aided together with a lot of NATs, and you've got architectural limitations due to lack of address space or just evolution of IPv4. And now you're going to limit your IPv6 architectures just because why? Right? So an addressing architecture really is the basis of designing a network infrastructure. And remember that whatever your addressing architecture is, that also will define your filtering rules and your boundaries, your network boundaries. So for those of you that may not have yet been doing anything with IPv6, what I would really encourage you to do is think about an address architecture. Forget about the fact that you have an existing IPv4 network, and just think about, if I didn't have what I had today, how would I want to build my network? And then, spend about a week or two thinking through an addressing architecture, something that will let you grow in case you make a mistake in terms of your allocations. And then see whether or not you can blend that with what you have existing today. Redundancy measures. Sometimes people use redundancy and think they're all, sane. I still remember when people first started utilizing, dual power supplies in their devices, and they would connect both of them to the same circuit. Well, that doesn't give you any redundancy, right? How many of you have done that? Somebody in this room has. Yeah. So you really have to think about, where are my single points of failures, and do I need the redundancy? And then if you do have backup systems, check periodically that the backup systems actually do work. There's enough war stories where, people don't test their generators, and then 2 years down the line, there's a hurricane or flood or something. It turns out the generator battery is drained. Bummer. Firewall load balancer placement. It's kind of interesting because people think, oh, firewalls, they're great. Let's put them everywhere, right? And sometimes, like, for example, if you're looking at a DNS infrastructure, right? I hate when people say, oh yeah, I want to NAT all the traffic going to my DNS server because I've got to protect my DNS server. DNS itself has a lot of resiliency built in. So now what you've done is you've created a single point of failure, and the firewall is going to fall over in a denial of service much quicker than actually the DNS infrastructure and system would. Right, so be careful about where you're thinking that you're going to put your load balances and your firewalls, and also understand, how much memory they have, how much state they keep, so that you find that they're not going to be the single point of failure for actually a system that works just fine if you, distribute the servers. IPv6 transition coexistence, right? The great thing is there's so many to choose from, right? So what you want to do is you really want to think very carefully about how you're going to implement IPv6. And in this day and age, anything you do with IPv4, your filtering, your access controls, anything that deals at the network layer, the IP layer, you should be doing the same thing with IPv4 and IPv6. So about 4 years ago, I had a project with a large cable company to do their security assessment for their IPv6 rollout. And the engineers were just starting to play with IPv6. They did an IPv6 enable, which in the Cisco routers would enable IPv6. And I took a look at their router configs, and I'm like, interesting. You have no filters on your VTY ports, right? So SSH, SNMP, like device access was totally in the clear. Now, of course, I'd have to know what the heck that long string was, to get access to the routers. But still, it was interesting to see that nobody even gave a thought about anything to do with security, right? It was just, can my IPv6 packets get from one end to the other? But they left their devices clearly in the open. You can't do that, okay? And this was even on production systems. So, I would just strongly encourage people to not do this. And there's more than, sometimes I talk in the hallways with varying conferences. People are like, yep, I did that too. Oops, Cloud paradigms. Cloud security is really frustrating to me because this is where I think people have created new jargon to mean the same thing. As far as I'm concerned, whether or not you use a cloud provider means that I don't necessarily have the manpower to, run my own network infrastructure and my backup servers and all that. I will rather trust somebody else, which is just fine, right? As long as you maybe have multiple different providers that you use. So again, you don't have a single point of failure with one cloud vendor over the other. And also, you've got legal implications. And I became somebody that actually started believing more in cloud providers after doing a bunch of consulting jobs a couple of years ago with smaller companies, and their networks were awful. They had Telnet everywhere. They were doing IPsec for VPNs, but using AH, which for those of you that may not know, this means you're only doing integrity protection. So they're all telling me, oh yeah, we're secure, we have VPNs. I'm like, but you're sending everything in clear text. No, but I'm using IPsec. Yeah, but you're using IPsec AH, right? And so what I realized is that there's not enough experts to go around to actually build secure infrastructures for all the companies. And so if you actually use a cloud provider, you know, hopefully they will actually have the expertise because that's what their business is. So they will probably keep your information much more secure. And then, of course, mobile traffic explosion. I mean, I don't think some mobile carriers realize that all of these are computers, right? And with all the applications, with all the potential malware that's been, you know, people can send around, it's kind of a scary thing. And mobile security, as far as I'm concerned, is in its infancy because there's very little control in terms of what people do. So that's really an interesting landscape. So let's take a look at some of the fundamentals. And I am not kidding when I say that the next 10 slides, if there's one of these things that you do not do, prepare an outage window and figure out how you're going to configure this in the next week or two. Because anybody that's a cyber criminal, you know, is fairly lazy. And what they do is they go after the lowest common denominator. You know, they're not going to start buying a whole ton of computers and trying to, you know, get at your sophisticated encryption technology. What they're going to do is try to figure out what you've forgotten to configure or decided not to. And the easiest things is what they're going to go after. And I'll guarantee you that they'll probably find a hole. Because I have done this for the last 10 years. I was just in India, actually last week, doing a 5-day security workshop. And I gave a list of 10 things that everybody should do and guaranteed there are at least 2 things on the list that people did not do. And these are the fundamentals that are no-brainers. So number 1, right, physical access. Don't stick a critical network device in a closet where other people may have access to them. You know. Access control. The one pet peeve of mine is group passwords. It's easier, right, to say knock staff, but if something happens, how do you then go back and figure out who it was, and then everybody has to remember a new password? It's much easier to have individual usernames, passwords for everybody. So if there's ever a compromise or a misuse, it's much easier to detect who it was. There's still devices out there that, you know, they're legacy devices. They do only do Telnet. You cannot do SSH. Well, don't then say that, okay, I've got a Telnet everywhere, right? Use a Jumphost inside your trusted network so that you can SSH internal to your trusted network, and then from there, Telnet to the devices that you need to. I'm not a proponent of that. I would prefer that you get rid of that device and buy something new, but that's not always possible. SNMP, my preference would be that people start using SNMP v3. Right. The one thing that people have been avoiding for decades is how to keep track of credentials. You know, how do you do public key, private key, and manage digital certificates? It was always a problem. It's like, oh yeah, we'll deal with that later. We'll deal with that later. Well, now with IPsec, with SNMP v3, with secure copy, with SSH, with DNSSEC, right, credential management cannot be avoided anymore. And one of the things that I've become a huge proponent of is that in organizations, right, there's varying groups that have to deal with credential management. See whether or not you could stick all of that under one group, because it's all a process issue, right? How do you create your credentials? How do you distribute them securely? How do you store them? How do you revoke them? And one group is not going to be as knowledgeable as the other. You know, again, I was in an environment last year where somebody came up to me and said, you know, an engineer, and said, you know, should I be signing this certificate signing request? And I'm like, absolutely not. It was to a vendor, which meant that the vendor could then, you know, pretend to be this company. I don't trust the vendor. You know, I don't trust anybody that's not the company. And, you know, I just had an engineer who was given the responsibility to do this. That's frightening to me. You know, so really we need to think about this. And, you know, who you give access to. I mean, with SNMP, it's interesting because, okay, it's useful to help in terms of detecting whether or not device interfaces are up or down, health of your devices. But it can give somebody with malicious intent a lot of information. So limit the views, right, and use integrity or encryption if you can to you know, provide confidentiality and integrity between the actual device and the server it's communicating to. Out-of-band management. Who here does not do out-of-band management? Okay, it's usually an issue with people that don't have a lot of money, right? Because you end up creating, you need more devices and, you know, other paths. So out-of-band management, though, is really the only way to go, because the minute that you hit a DDoS, you can't get access to your devices, right, if it's in-band management. This one is something people do not do. It's fascinating to me. So, you know, there was a couple years ago that it was actually Juniper, and this was widely publicized. Somebody actually managed to create a backdoor and mimic their operating system. So people downloaded, you know, the whatever version of Junos it was, and somebody had a backdoor into the routers, right? All you would have had to do was check the MD5 checksum, and you would realize that it didn't really come from Juniper. You know, it was a miscreant kind of operating system. And these things are scary, and all you have to do is have the process in place, check the MD5's checksum. Another thing that's really interesting to me is that TFTP is still extremely widely used. And I'm in environments and I'm going, so, okay, and so where you're TFTPing from, right? And sometimes the servers actually sit somewhere where in the path in between, it's fairly easy for somebody to run Wireshark and sniff the traffic, right? I mean, that's kind of scary to me. And secure copy, you know, why wasn't secure copy used? I'll tell you, it was interesting. This is 6 months ago. I'm in an environment, and the vendors are creating some new protocol for a new device, and they're using TFTP. And I'm like, why not SCP? You know why? Because the actual mobile carrier didn't have a process in place for credential management. You know? And I did not understand that, but these are the realities. So, you know, I would encourage everybody, if you're still using TFTP, try to get away from that, use secure copy. FTP, same thing. You know, the other day somebody was telling me to FTP some logging data from somewhere that had to do with an attack. And I'm like, FTP, seriously? I was sitting in India, I was starting to do it, and then I'm like, wait a minute, I'm in India, I'm in a wireless network here, I don't know who else is gonna see this, right? And I'm going, why didn't you provide secure copy? Right? Because these are all vectors for people to get information to then potentially attack your networks. So this here is a summary list of all of these should be implemented in your network. Use it as a checklist. You know, if you go back or you look at your infrastructure and, you know, you decided not to do one of these, go back and fix it. And I'm pretty serious about this, because it's amazing when you start looking at how attacks actually were able to be successful. And primarily, it's one of these things that people just said, don't feel like it. You know? And yes, some of you might be resource constrained, but quite frankly, this is not that difficult. You know, you can knock this out on most devices in an hour. You know, at least create the template and then it's cut and paste. And if you have scripting available, right, and if you have hundreds of routers, then, you know, hopefully you'd have some automated tools to actually do this. So infrastructure filtering. Filtering is, you know, always a love-hate relationship with people. It looks really easy, but then, you know, can really get kind of complex. So I understand why people don't want to do filters. You know, if you've got hundreds of thousands of endpoints, right, it's a pain. And every time you touch a filter, you probably break something. So you want to think really carefully about it. But infrastructure filters are critical. And the reason why is because they will protect your infrastructure devices, you know, mostly your routers, your switches, your VoIP servers, whatever. And so the basic premise is that you filter traffic destined to your core routers. You want to develop a list of required protocols that are sourced from outside your autonomous system and access the core routers, such as eBGP peering, generic, whatever, GRE tunnels, IPsec. And you also want to identify the core address blocks that are used. So there was an RFC 3330 that was created for special use IPv4 addresses. The reason I list them is because my recommendation is always to filter out any traffic that's sourced from these IP addresses, right? Because it's obviously spoofed. And a couple of years ago, I was giving a talk specifically on filtering, and it was pointed out to me that that RFC is quite dated, and that some of these subnets actually are now being used in real life. They've been reallocated by the RIRs. So something I always say when I give to the security talks is trust but verify. You know, don't believe anything. You know, just validate. And, you know, yes, it's not easy. You know, actually making sure your networks are secure. I mean, you know, you can't just read one thing and say, oh, look, I'll just do this. You really want to think about, you know, is this appropriate in my environment? Also, since we should be thinking about V6 as well at this day and age, these are the special use prefixes also that with IPv6 I would actually filter out. So I would do ingress filtering, right, traffic coming to my network that would actually deny any traffic with these specific addresses as sources. Another thing about filtering is that it amazes me how many people don't log their exceptions. You know, and I'll have some slide that talk about logging. Logging is extremely difficult because you always have too much information, right? But I'd rather have too much information than too little, because, you know, there's always scripts that you can write to actually try and decipher the information that's relevant to you. And I always filter my, log my filtering exceptions. Why? Because if there's traffic that's coming that are, you know, exceptions to my filters, that means that traffic should not be there. And I want to know whether or not it's somebody that's doing reconnaissance or not. Fragment issues. Okay, reason I put that here is because fragmented packets are very often used to bypass some filtering rules. So you need to understand how devices actually handle fragments and what they do with it. And as a reality check, right, routers and switches really should not be receiving any fragments. So, you know, in terms of management and control plane packets, they should not be fragmented at all. Okay, routing infrastructure. So, you know, within routers, they usually have various queues that are used as well, as a way that okay, let me rephrase here. So within routers, what you want to avoid is anything that touches the CPU. Okay, and you want to forward packets as quickly as possible. BGP obviously is more used, so most of these slides will deal with BGP type of issues. A few years back, it was it became common knowledge that if you send a TCP reset packet, right, you can tear down your BGP session, and depending on how many sessions you have, you know, it might be tens of thousands. It could actually take quite a while to rebuild up your BGP tables. And so some people thought, hey, you know, I mean, really, my peer is only one hop away. And so to provide some protection, why don't we just do this thing which started off being called the TTL hack, which basically says that, you know, rather than you know, starting off at the, whatever, 255 hops away where you decrement, right? Why don't we just say that you can only be one hop away? Because that way, if somebody's trying to send some malicious packets, right, and they don't have just the one hop away TTL, I'll just drop the packet. So this was thought as a pretty good idea. It was such a great idea, actually, that within the IETF, the Internet Engineering Task Force, where all these you know, internet standards are created, that this went from an idea to actually a standard within 1 year, which is unheard of. Usually there's lots of arguments. It takes 4 or 5 years, and God knows what, you know, before something becomes a standard. But this TTL hack became a standard within 1 year. Now, the problem is, though, that there were other events that happened in the US, 9/11, that happened around that time, and some other things that the vendors didn't quite make implementations that were interoperable. So every now and then I still see discussions on an analog list or other operational lists where people are like, yeah, this is a really good idea to implement, But if you're doing, using it from one vendor to another, you may have interoperability problems. Rather than give up and say, oh, forget it, the vendors are idiots, let's not do it, I would rather look at it the other way to say, you know something, we as users, right, we should go to the vendors to say, fix this, because this gives me one more thing that will provide some additional mitigation management. And so, the configuration is a one-liner, right? It really shouldn't be that difficult, so interoperability issues should not exist. Okay, MD5 authentication, pain in the butt. You know why? Because key rollover is a pain in the butt. None of the vendors do it right. They don't do it in an interoperable way. And I had written a book on network security. It's Cisco Press book, came out in '99. I did a second edition in 2003, and I specifically added a chapter on route security. And what it was actually detailing the MD5, or rather integrity checking for RIP, OSPF, ISIS, BGP, because all of the RFCs in 2001, 2002 were written such that you should be able to do MD5 authentication and have at least 4 keys. So why the implementations are so horrible, I have no idea. It doesn't make sense to me. And so there was just recently a thread on NANOG again about a month ago about should you do MD5 authentication. And some people say, well, it's marginally useful, and the reason that it's useless is because the key management and the rollover is atrocious. So again, it's something that if I was an ISP and I had money behind me, I would tell the vendor that fix this or I'm going to somebody else. Now, if nobody else is doing it, there's a problem, right? But I think these kinds of things really should work. These slides here are more to say that, filter, do prefix filtering, and put in maximum prefix limits, because there's a lot of accidents that happen with people sending out more specifics and you black hole your networks. So actually, if you do some kind of prefix filtering, that will help. There's also RPKI that's getting somewhat popular. It allows you to verify whether an autonomous system is authorized to announce a specific prefix, okay? That is all that it does, right? And there's actually 2 camps. Some say that, look, this is still useful. I mean, you really should use RPKI. There's other folks that say, well, the real problem is routing leaks, and does not solve the issue for routing leaks. So, why go through all the trouble of creating these certificate, authorization chains? Is it too much trouble for what it actually buys you? I currently don't have an opinion on it yet. It's too new. But the following pointers are all, information that I think would be useful to you to actually look at. And, specifically look at the ones from the RIPE region. Okay. MPLS, how many of you run MPLS networks? Okay, a few of you. It used to really, I used to laugh when people said, oh yeah, we're secure because we run MPLS VPNs. I'm like, really? Okay, what's your integrity protection? What's your encryption, right? I mean, just because you say the word VPN doesn't mean you're secure, right? It means that you're sharing network resources. And so from an MPLS point of view, you really still have to think about how you're going to actually secure traffic going through MPLS. So some recommendations are, use authentication and encryption technologies such as IPsec, HTTPS, use MD5 authentication between LDPs, and do monitoring. So here's a couple of other recommended nuances. So, most of what you'll see in terms of when you're securing things, you're either providing integrity checks, right? And integrity usually means that you're using some kind of technology where if I'm communicating with you, that you can be fairly secure that the packet came from me and that nobody actually changed it in transit, right? And you really should think about that with any kind of communication that's important to you, be it voice over IP, being MPLS packets, routing packets. So, and to me, really, the integrity is much more important than confidentiality, right? And people usually talk about VPNs and think everything's encrypted, and I'm like, not really. I mean, if you only provide integrity and, you know, origin authentication, to me, that's much more critical than really encryption, because usually confidentiality is a policy decision. But you want to be much more certain that, you know, you're communicating to the right party and that nobody's actually changed anything in transit. DNS. DNS is the ugly stepchild, right? Only in the last couple of years have people really looked at, you know, DNS really is important. And look how easy it is for somebody to circumvent DNS. It is quite scary. I don't know if it's the same here in Poland, but I certainly know through my consulting activities in the US and in some other areas that the first thing I ask is, so, who's your domain registrar? Oh, so-and-so. How many domains do you have if it's a large company? Well, we don't know a lot of them. You know, again, for a large mobile carrier, I was asked to re-architect their entire DNS infrastructure. This is a large global carrier. And the first thing I asked was, well, what domains do we own? Legal's looking into that. That scared me. Yes. And they're like, you want to know all of them? I'm like, I want to know all of them that I used. And I finally got, you know, the 28 sheets, the spreadsheet that gave me all of them, right? And then started down the track. But you laugh. I wonder how many of you have the same thing happening in your environment if you're a large entity. I don't know, right? Go and find out, you know, what's done with your DNS. It gets kind of fascinating. So, you know, there's lots of vulnerabilities, right? Primarily cache poisoning or DDoS. You know, it's DNSSEC. Absolutely consider it. There is a mailing list called DNSSEC Deploy or DNSSEC Deployment. I just got on it about a year ago. I love it because I can see all the mistakes people are making, you know. And honestly, the primary mistake is key rollover, right? So credential management sounds really stupid, sounds kind of boring. It's a very, very important thing, right? Because you don't want to get caught up in not having the right process. Logging, auditing. The server should be physically and logically secure, accept messages only from trusted hosts. Integrity, protect your logging messages, encrypt, and what about privacy issues, right? There are countries where IP addresses are considered private information, right? I just had a conversation actually with a former regulator here asking what the situation was in Poland. It's something to be aware of and track. I had my 5-minute warning probably about 4 minutes ago, so I'm just going to go through this quick. Syslog, right? If you can, please use Syslog NG, something that provides integrity protection. Again, most people send valuable logging information just in clear text. And I do not trust the internal of my network anymore because I do not know whether or not somebody is going to use something for malicious behavior or not. And the first thing that miscreants do is they cover their tracks. So logging information, absolutely, I want it to be integrity protected. Here's a couple log analysis tools. NTP. I used to love 5-6 years ago, they came up with these, you know, $50,000 boxes to correlate my logs, right? And I said, well, how do you ensure that the timestamps are synchronized? Huh? Right? I'm like, oh, great, nice. You know, all these logs, right? Nothing correlates. Throw it away. Netflow, also SFlow, right? Gives you really good, quick information about, you know, who's communicating with who, what kind of traffic you get, and it's kind of a quickie to let you know if there's anything funky going on in your network. Open source tools available. Also, I recently found out, because I hadn't really looked at it, that TACAX Plus has an open source version, so that's kind of cool. This slide gives you some tools. These are all to, you know, run them, they're free, and do some penetration testing in your networks. You don't have to pay money to have people penetrate, you know, doing testing, because what a lot of these people do is they download these tools and, you know, hit go. You could do that. Routing is a security tool. I'm not going to have time to talk about this in detail, but look at the slides. Create sinkholes. So sinkholes are a way to, you know, null route traffic. So you can actually then point it to a specific server, and later you can do analysis on it. So you can create a sinkhole very easily. They don't have to be complicated. You can, play with it if you have a little bit of time. It's taken 2 hours, and just download a couple of tools, see whether or not you can divert some traffic, and see how useful it might be. And this is what you can do to actually use sinkholes. I mean, it's used to monitor scans on dark IP addresses, so the ones that are unallocated or unannounced. Also bogons, the unallocated addresses, backscatter from attacks. And this really gives you a lot of reconnaissance for bad activity that's happening on your networks. Also remotely triggered black hole routing. Who in this room knows what that is? Okay, about half of you. Yeah, so it's a concept that is not that difficult, really. So basically, you're using BGP routing to create filters on, hundreds of routers on your border, right? So what you need is you have one router that gets configured as a trigger router, and it will actually define a subnet, usually a darknet space, that's then points to null 0. And when you know that there's an attack coming, then from that IP address, what you do is you send that all to that particular darknet space. You propagate that via BGP so that all the edge routers then, what they will do is when they hear traffic from that source, they will just black hole it. So there's some specific slides on that. So what you have is, there's a provider edge routers, attack traffic with the bold red lines, and then BGP updates. So first thing you do is you prepare a trigger router and also the edge routers configured with static route to unused space. And then once you figure out what the target is, you do have to configure the trigger router once you know what either the destination attack target is. And then BGP will actually take care of applying the filters to all the edge routers. So the problem is if you do a destination only, then if there's still legitimate traffic that wants to get to the destination, right, that gets black holed also. So that's, you really want better granularity. So then they came up with a technique that's source-based remotely triggered black hole filtering. So pretty much very similar to destination-based, except you also use unicast reverse path forwarding, URPF. And what that does, URPF is basically if there's traffic that's coming into your device, if you see it in your routing table or your forwarding information base, then you know it's valid traffic. If it's not there, you drop it. So here's actually a configuration example for Cisco router. Couple of considerations because you do want to play with RTBH in your lab because you don't want to end up creating a situation where you're dropping legitimate traffic. And so here's a summary for best practices. So use least privilege mode where possible. I will stress again, when implementing IPv6, don't forget to filter all of the traffic, same as you do with IPv4. Your infrastructure filters, your accesses for console, for SNMP, and whatever. It's just good practice. And if you're not using SNMP or syslog in v6 transport, just do a, deny all, right? At least create that filter just in case. You can read all these later. Any questions? I think I have 10 seconds.
Any questions?
Everybody doing all of this? Yeah.
Thank you very much for
all
the
right.
presentation.
Thank you.